Okay, let's remind ourselves about the different stages of database development, and then we will continue with our current tutorial. So just as a reminder, there is a problem setting, a problem domain, for which we want to develop a database. So the first stage is you examine the problem domains, understand it, and then the first stage is get the requirements. Okay, so in that stage, you talk to the end users, try to get an understanding of the problem setting for which you're trying to develop the database. Okay, and then in terms of actually getting down to doing the task, the first major step, you may remember, was data modeling. The output of which was the conceptual data model. This then feeds into the next step, which is database design. And then you go on to database implementation and operation. Okay, so up to now, all the tutorial that we've been seeing up to now, our emphasis was on this conceptual model. What is a conceptual data model? How is it represented? And we spent a lot of time on the various conceptual foundations of the entity relationship model, because this is a graphical language that is used to express the conceptual model. So as a reminder, the conceptual model is simply the content of the database. So after you have analyzed the requirements, you design the contents of the database, but in a very structured way. Very structured meaning you set up the database and you identify two components of that structure. One is the set of entities and the other is the relationship. So we spend most of our time so far in the tutorials trying to understand the concepts underlying the entity relationship model. Okay, things like entities, relationships, one to many, many to many, and so forth. What we did not spend a whole lot of time on, we did a little bit, but not a full-fledged exercise of how do you actually get from requirements to the ER model? How do you get from requirements to the entity relationship model? So we didn't actually do a full-fledged example of the modeling exercise itself, how to get from A to B, how to get from here to here. Okay, so we're going to go through a full example again. It's a little bit of a toy example, but still it'll be more comprehensive than the examples that you have seen so far. And as I go through the example, what I'd like for you to focus on is try and get a sense of what it is we look for in the requirements. So when we're looking at the requirements for the application, what is it in the requirements, in the text, the forms, the content that is given to us in terms of the requirement? What is it that we look for in the requirements that helps us identify the entities and the relationships that make up the conceptual data model? Okay, so with that short introduction, let's look at our setting. So the application that we're looking at here, again, it's a hypothetical example. This is an interior designer by the name of Heather Sweeney. And here you have a few bullets. Now in practice, this description again might be 100 pages long, 50 pages long, but we have sanitized it here. We've simplified it here for the sake of our discussion. So Heather Sweeney is an interior designer, and you are going to design a database for her to support her business activities. So in these few bullets that you're seeing, you're getting a verbal description of different aspects of the business. Okay, so what is it that this business does? So first thing you see is this is an interior designer who specializes in home kitchen design. So it's not any kind of design, but she specializes in designing home kitchens. Okay, so all right, so that's one piece of information that will feed into our design at some point. We don't know how, but it's a piece of information that we have. And now you look at the following sentences. Okay, so she offers a variety of free seminars at home shows and at kitchen and appliance stores and other public locations. So she gives seminars at different locations. All right, and you go into the next bullet, you can see that she also sells books and videos. Okay, and she also offers custom design consulting services. So you have in bulleted form here a description of the business activities that go on for this consultant. What we try to extract from this initial description of the business before getting into further detail is what kinds of things might we want to store information about. In other words, what are the entities about which we might want to store information in the database. Now, again, this is not hard and fast, and it's an iterative process, you will see. But right off the bat, I can see that Heather Sweeney as a consultant will have customers. Okay. And these are customers, and they can be different types of customers. Some of the customers will be buying her books. Some of the customers will be buying her videos. Some of the customers would be taking advantage of her custom consulting services. And some may be doing all three of them. Okay. But in any case, she has customers. And that would be one type of entity about which we will want to store information in the database. So very likely there will be an entity called customer. And at the moment, I don't need to dive in and try and decide what all do I need to know about a customer. I know I will need to know the name and address and phone number and things like that. But beyond those obvious details, attributes, what else about a customer I might want to know, we'll worry about it. We'll get to that later. Okay. So second thing, again, this is a first cut guess of mine. This consultant, Heather Sweeney, is selling books and videos. Okay, so it seems to me that she has some products that she's selling. Okay, she has some products, and in this case they're books and videos. Perhaps later on she might generate some mugs or plates or whatever other kinds of products through which she might want to earn revenue. But at the moment she has books and videos. There are at least two types of products that she wants to sell to the customers. Okay, and then when I look at the second bullet, it seems like she attends seminars, home shows, kitchen, and she goes to kitchen and appliance stores. So there are a variety of events. I'm just calling them events for now. Maybe we will find that that's an appropriate name, maybe not. But it seems to me that in this particular business setting, events are also a type of entity about which we might store information. So an event could be a home show, an event could be a seminar, and an event could be something held at a public location or at an appliance store. Okay, so these are at least three entities about which we might want to store information in the database. So just by reading the text, the first thing I'm trying to do is trying to get a sense of what are the entities about which I might want to store information in the database. So those will be entities in the ER diagram. And this is just my first cut. So I will come back, and as I know more and more about the application, I might revise this list of entities. I might throw out one or two of them. I might add some new ones. So for example, I'm not adding a particular entity, but it seems to me that if Heather Sweeney has customers, that she will want to contact them also. She'll probably want to write to them. She'll probably want to call them just to keep in touch with them and ask them, do you want to buy any of my products? Do you want to attend any of my events? Do you want to take advantage of my consulting services? And then maybe once she does sign up a customer for a consulting engagement, then maybe there might be another entity that stores information about consulting engagement. So I'm just taking a guess now from this first read as to what type of entities might be present in the application. Okay, so that's the starting point. Now, so this description that you're seeing is just a textual description of the business, and this is a very simplified one, but this is what you would see in general as a starting point. Now, next, here's a sheet describing the Heather Sweeney's customer list. So right now, let's say it's manual. So maybe this is at a seminar. She gave a seminar somewhere maybe, and this is the list of customers that attended that particular seminar. So how is this useful? Why is this sheet, sign-up sheet, useful for me for database design? You can pick up a lot of information from this. For example, I can see that for the customer, I certainly need to know the customer's name. Then also you can see here that I have gotten the customer's phone number. So you get ideas of the attributes that you might want to put into some of these entities as you build them up. Okay. So you also have the email address of the customer. Okay. So you have a location for where the event was held. That tells me that one of the attributes of an event will be the location where the event is held. Then the event has a title, let's say Kitchen on a Budget. Okay. Then there is a time and a date for the event. So just by looking at the sign-up sheet, I get ideas about how to fill in certain details about the entities that we thought about in the previous slide. Now, you might also get ideas about additional entities that you would need. So gradually you are getting more and more information about the application setting. But let's say just with this as a starting point, how can we begin to build the entity relationship diagram? So again, coming back to our original diagram where we started. So remember, we are focusing on the data modeling process. What is the process of getting from requirements to the ER diagram, to the ER model? Okay, and we are gradually going through that process. So, okay, so based on that little description that we saw and that sign up sheet, here is my starting point. I have identified two entities, one called customer and the other called seminar. Okay, and we put a relation, and I'm connecting them by a relationship. Because why? Just by looking at this sheet that you saw in the previous slide, I can see that there are lots of customers. In this case, you see just 27 names in all. So in one seminar, there could be multiple customers. All right. So right from that one sheet, I have drawn this very simple ER diagram. I have two entities, one entity called a seminar, okay, and a second entity called customer. So remember, when we started off our discussion, I didn't have any entity called seminar. Rather, I had an entity called events. So, an event. So she gives a variety of free seminars. So these events are actually seminars, and they are at different locations. So instead of calling them events, it might be nice to just call them seminars. So this is we have an entity called seminar, and we have an entity called customer. And here you can see a few attributes for each of these entities. Where did these attributes come from? Okay, you go back to that sheet. You can see that this particular seminar had a date, it had a time, it had a title, and it had a location. Okay, so do you see there's a seminar title, location, time, and date, where these attributes came from? So just by looking at that sheet, after all, Heather Sweeney is not a database expert, not a database specialist. You don't expect her to know what an attribute is, what an entity is. You, as the database designer, would need to look at the information she gives you about how her business runs and the various documents and reports that are used in the business, and you have to figure out what are the entities, what are the attributes that you would need to structure in the database itself. Okay, so we have one entity called seminar, we have another entity called customer, and I think you can guess now where these attributes came from, again looking back at the sheet. So for a customer, you have the name of the customer, you have the phone number, you have the email address of the customer. Okay, so you can see for email address, phone, and the name. Okay. Now, you remember from our study of the ER model and the entity relationship model, every entity must have an identifier. An identifier is an attribute or a collection of attributes that uniquely identifies an instance of that entity. So we have to ask ourselves, what should be an appropriate identifier for seminar? What should be an appropriate identifier for the customer? And the question marks here simply means that we haven't figured that out yet. Okay, so we'll build up the ER model gradually, but we haven't figured out the identifier yet. We will need to do that. Okay. Next, in this case, we have a relationship between the two, and that's every relationship is represented by a dotted line. Most of the relationships are represented by dotted lines. You know that from our previous videos. So, and every relationship must have cardinalities. Okay. So just by looking at the sign, so these are the cardinalities. Okay. And we have to ask ourselves, are these cardinalities correct? So just by looking at this diagram, what we are saying is one seminar is associated with at least one and at most many customers. Remember how the cardinalities are written, are interpreted. So if I expand this on the right hand side, you have this symbol and you have this. Okay, this is over here, and the inner symbol is always the minimum cardinality. The outer symbol is always the maximum cardinality. So when I go from seminar to customer, I'm saying that one seminar is associated with at least one customer and at most many customers. Okay, I think you would agree that and there can be many customers at a seminar. In fact, you hope that there are many customers at a seminar. But I'm not entirely sure if this minimum is correct. We are saying that there should be a minimum of one customer at a seminar. Now, this would, whether that's true or not, that would depend on how you run your seminar. For example, you might say that if I don't have even one customer, I'll cancel the seminar. That it doesn't make sense for Heather Sweeney to go and hold the seminar. So there should be at least one customer. So if that's the case, then if a seminar is held, then there should be at a minimum one customer, and this cardinality would be correct. However, if you allow a seminar to be posted and announced even when there is no customer, then the minimum cardinality should be 0. Rather, let me draw it properly. Then the minimum cardinality should be 0. Sorry. The minimum cardinality should be 0 and the maximum cardinality should be many. Okay. But on second thought, I think this looks perfectly fine. And I wouldn't run a seminar if there isn't even a single customer. So I think it's perfectly okay to say that one customer is associated, one seminar is associated with at least one customer and at most many customers, going from left to right. Okay. Now, when I go from right to left, you look at this cardinality, and let me expand it and blow it up. So you see 2 1s. So this is the minimum. The inside symbol is the minimum cardinality. The outside symbol is the maximum cardinality. So when I go from right to left, from customer to seminar, what I'm saying is one customer attends. So I'm going from right to left. One customer attends at least one seminar. So this is a 1, and this is also 1. So one customer attends at least one seminar and at most one seminar as well. Okay, so this is what the symbol says, and I'm not entirely convinced that that is correct, because you could have a customer who says, oh, I will come to your seminar, and then finally doesn't show up. And it's also possible that you could have another customer who attends 5 of Heather Sweeney's seminars. I don't see any reason why a customer should be restricted to attending only one seminar. They might attend more than one. Okay, so what I'm sensing is, again, I'm not going to complete the drawing now because I would need more information, but so my hunch is that this left side, the picture should look like this. Okay, that is, when I go from customer to seminar, one customer attends at least 0 seminars and at most many seminars. I think you certainly want to allow a customer to attend many seminars. So, but it's possible that in order for the person to be a customer, they should have at least attended 1 seminar. So I think one can make the argument that the left-hand side cardinality should look like this. So one customer attends at least 1 and at most many seminars. Okay, so I hope you're seeing how we are gradually starting to build the ER diagram. Not everything will be nailed down and precise in the first go around. We'll go back and forth, but this is a starting point. And the important thing to notice here is how did we what did we look at in the inputs, that is the description of the business that was given to us and the various forms and reports that are used. How did we extract the information from that input, from the requirements, to start us on our path to construct the ER diagram. Okay. So my hunch was correct. Okay, so we have revised the ER diagram here. Do you see? So let's look at our starting ER diagram. It's the cardinalities. So focus on the cardinalities. The way this particular relationship was drawn, what we are saying is one seminar is attended by many customers, but we were saying that one customer could attend only one seminar. This was set up as a one-to-many relationship, and that doesn't make sense if you reflect on it a bit. Now, do you see that this is a many-to-many relationship? Okay, so look at the cardinalities here. Again, the minimum cardinality is 0, the maximum cardinality is many. Okay, similarly on this side, the minimum cardinality is 0 and the maximum cardinality is many. So this is, I think, in my opinion, this is a more accurate reflection of the business setting for which we are trying to design the database. Also notice one further refinement. We have set up the identifiers. So the identifier for customer is the email address. Every customer has a unique email address. Now for seminar, there is no natural identifier, so we have to cook up an ID for it, and we'll just give it a seminar ID, an identification number that identifies a seminar uniquely. Okay, so we now have identifiers for the two entities, and we have the relationship between the two. So the way I would read this relationship is one seminar can be attended by at least 0 and at most many customers. And if I go from right to left, one customer attends at least 0 and at most many seminars. So this is a many-to-many relationship between seminar and customer. Very well. Let's move on a little bit further ahead. Okay. So now Heather Sweeney comes along. I need a little bit of tea here. Okay, so Heather Sweeney provides you with another piece of information from her business. She gives you an example of a letter that she sent to one of the customers who attended one of her seminars. And she says, "Dear Ms. Jacobs, thank you for attending my seminar, Kitchen on a Budget, etc., etc. As a seminar, you are entitled to discounts on my video and book products." So, and then she also goes on to say that, hey, I also offer customized design services, and maybe you want to take advantage of those services. If you want, just call me at this number and so forth. Okay. Now, why is this letter important? How is this useful to us in continuing to build our ER diagram? Okay. The first thing you notice from this letter is that this is the first time you're seeing, not the first time rather, but you're seeing the Heather Sweeney trying to sell products to the customer. So video and book products. So you immediately know that somewhere in your database, you will have to have an entity called products, which keep track of the things, of the videos and books that Heather Sweeney is trying to sell to customers. Okay. The other thing that you can see from here is that Heather Sweeney does contact her, sends letters out to her to her customers. Okay, now she might be calling them also. So there is some kind of relationship between Heather Sweeney and her customers that consists of communication between them to help her drum up more business beyond the seminars. Okay, so let's move on ahead and see how the information from this particular letter, how that helps us build the ER diagram a little bit further. Okay, so here is a little bit further development now. This top part of this part, the relationship between seminar and customer, we have already discussed. Now, what has been done over here is a third entity called contact has been identified. Okay, what do we mean by contact? It's something that Heather Sweeney has sent out to a customer. This is typically a letter, but maybe it could be a phone call also. Okay, and the contact, you remember from the letter, just remember the text of the letter, just thank you for attending my seminar. So the origin of the contact was the seminar. So when the customer reads the letter, they will remember, oh, I went to this seminar called Kitchen on a Budget on such and such date. Okay, and the customer will remember what that seminar was about, and perhaps proceed to get more business, have more business relationships with with Heather Sweeney. Okay, so here you have this entity called contact, and look at the attributes of contact. So you have a contact date. Okay, because you can see it. Look at this letter. This letter should have a date somewhere. So when was this? So it doesn't have the date itself on the letter. It should be there somewhere. Okay, this letter must be sent out on a particular date. So you have the contact date. The contact type is a letter. I assume this letter is a form letter. This is the standard letter that goes out. Okay, and here you see it's a contact number. So perhaps Heather Sweeney sends out more than one letter to the same person who has attended the seminar, perhaps as a reminder. Now, we get such reminders from automobile dealers all the time. If you visit an automobile dealer's shop, you will get more than one contact from them. Okay, so basically this entity here that you see is an attempt to capture information about how Heather Sweeney has tried to keep in touch with customers. Okay, and what was the mode of that particular contact. Okay, so just as before, we have the attributes, but we haven't yet set up an identifier. We'll figure out the identifier a little bit later as we get more information. But the next thing, of course, is, okay, we have this entity called contact. How is it related to the other two entities in the database? So you can't have a database where an entity is just sitting there by itself, not connected to anything else. Okay, so a database will ultimately consist of entities which are connected to one another in terms of content. Okay, you can't have an unconnected entity just sitting there by itself in a database. So clearly there's a relationship between customer and contact. Okay, so this letter that you just saw in the previous slide was sent out to a customer, and you could be sending out more than one letter to the same customer. Okay, so if you look at this particular relationship between customer and contact, it makes sense that it's a one-to-many relationship. So let's go at it from both ends. So the cardinality on the contact side looks like this. Okay, so how do I interpret this cardinality? The way we interpret it is, I'll start from customer. So one customer is contacted at least 0 and at most many times. So do you see how I came from customer to contact? So one customer is contacted at least 0 and at most many times. The inner symbol is the at least, the outer symbol is the at most. Okay, now if you go in the reverse direction from contact to customer, you look at the two cardinalities here, the at least and the at most. So these are both ones. Okay, so if I start from contact, we'll say one contact. So this could be a letter or a fax or an email, what have you. One contact is sent. So I'm starting from contact and going to customer. One contact is sent to at least one and at most one customer. Okay, at least one and at most one. Obviously, you don't send a contact to nobody, so it can't be at least zero. So at least one and at most one. So we've interpreted the cardinalities here, and this is a one-to-many relationship. Okay, so and now if you look on the left hand side, why is there, first of all, why is there a relationship between seminar and contact? If you look at the letter, you can see that thank you for attending my seminar. So the origin of the contact was a particular seminar. So the source of the contact is the seminar because the customer attended the seminar, and that was the origin of the contact being sent out by Heather Sweeney. Okay, that is, so it is simply the content of the letter that tells me that there should be a relationship between seminar and contact, because when I send the contact, I must be able to connect it with the seminar that generated that contact. Okay, so now, so I know that there is a relationship between seminar and contact, but what is the nature of the relationship? This is a binary relationship because it is connecting two entities, but what are the cardinalities? The cardinalities are usually the most difficult to figure out. So again, let's look at the two of them. On this end, I'm just blowing up this, expanding this cardinality on the extreme over here. So if I go from seminar to contact, so one seminar generates at least zero and at most many contacts. So at least zero and at most many contacts. Okay, so I think that makes sense. That a seminar might not generate any contact, but may also generate many contacts. So that's why you have the circle and the crow's feet. The crow's feet, remember, is a corrupted form of the letter M. Okay, so one seminar generates at least zero and at most one contact. Okay, now if I go in the reverse direction, okay, so one contact is generated from at least zero and at most one. So this is, again, if I blow up this particular cardinality, it looks like this. Okay, so the minimum is zero and the maximum is one. All right, so if I start from contact in the reverse direction, one contact is generated by at least zero and at most one seminar. Okay, now I think I agree that a contact can be generated from at most one seminar because that's the source of the generation of the contact. I'm not entirely sure that the minimum should be zero. Maybe this should be a one also, but I suppose it's possible for Heather Sweeney to come up with a contact that did not result from a seminar. So the contact came from somebody else, maybe a friend recommended the contact, but then the letter would be written slightly differently. But it's possible that the contact was generated not from a seminar. So I'm willing to accept this minimum cardinality of zero. So let me repeat. Then one contact is generated from at least zero seminars and at most one seminar. Okay, so here we are. We have built this ER diagram a little bit further. So again, another aspect of building ER diagrams, ER models, entity relationship, conceptual data models, is that you build them gradually. You will not be able to figure out all the entities and all the relationships in one fell swoop. In fact, as you progress through the development, you will maybe create more relationships, maybe delete one or two here and there. So it's an evolutionary process. Okay, and I hope you're seeing that as we go along. All right, so now we are going to refine this picture a little bit further. Okay, so what we are saying here, so just notice the difference between the previous and ER diagram. So you have three entities here: seminar, customer, and contact. Okay, and you got three relationships also. Each of those relationships are binary relationships. But now, we have refined the picture a little bit. So how have we refined the picture? We still have three entities. We have customer, we have seminar, and we have contact. Okay, but notice now that the contact entity has been drawn slightly differently. It is still rectangular, but the edges are rounded out. Okay, the edges are rounded out, and you can see that one of the relationships is now drawn with a solid line. One of the entities is one of the relationships is drawn as a solid line. Furthermore, if you look at the identifier of contact, look, this is the identifier of the contact. Do you see that it's a composite identifier? It consists of email address and contact date. So this email address, you can see, came from here, from the customer. So contact is a weak entity. We have set up contact as a weak entity, and this solid line that you have from customer to contact, what this is basically telling me is you cannot have a contact without a customer. So the entity contact cannot exist without a customer existing. Obviously, the contact letter is written to a customer, so it makes sense to set it up as a weak entity. And in this case, this is an identifying weak entity. So this is an ID dependent weak entity. Why? Because the identifier of the weak entity contact consists of the ID of its parent, namely customer, plus something else. In this case is a contact date. So let's say you send out three contact letters to the same customer, all three contacts. So if I were to draw it like this, so there are three contacts, you send out three letters to the same customer. All three letters would have the same email address, but the contact dates would be different. Okay, you would send them out on three different dates. So the composite identifier would be different for all three contacts. Okay, so we have refined the picture, the ER diagram, from what we had previously to changing contact to be a weak entity, simply refining that picture based on further analysis of the business application, namely the fact that you cannot have a contact letter go out before you have a customer. Contact can only exist because of the existence of the customer. Okay, all right. So now here what we have, what's being done again, let's trace the changes as we are going along. So we have three entities, we have customer, seminar, contact, and so forth. What we're doing now is taking the entity customer in the next step and just refining it by adding more attributes. Okay, so in addition to the last name, first name, and email address, we have the city, state, zip, phone number. Where would these attributes come from? Perhaps Heather Sweeney has shown us more forms, other business communications that they have with the customer, from which we get a sense of all the different attributes that must go into customer. Okay. Now here is a third piece of information that Heather Sweeney gives us. Heather Sweeney is showing us a sales invoice. So here Heather has sold something to a customer, and you as the database designer, she just said, oh, here's an example of the invoice that we sent out to this particular customer. So Heather, again, remember, Heather is an end user. She knows nothing about ER diagrams. She knows nothing about entities, relationships. It's your job to look at the information requirements of the application and from it figure out what entities and relationships you need to create in your database, in your conceptual data model. Okay, so our job is to look at this invoice. This is a business document, and from it figure out what else do we need to put into our ER model, into our conceptual model. Okay, now what are some of the things that I can pick up from this invoice? I can see that customers have this address. They have address, city, phone, state, zip, and so forth. So in the previous refinement, you already put those attributes into a customer. So coming back now to the invoice, I can see that I will need to have an entity called an invoice. Okay, that this document itself tells me that I need to keep track of my invoices, because an invoice will have an invoice number, okay, and it has an invoice total, a dollar amount, and so forth. And you can also see that invoice refers to some products. Okay, in this case, one is a video, another is a video companion. So there are two small videos, I suppose. Okay, so there's some product information in this invoice also. So that leads me to guess that in addition to having an entity called an invoice, I might also need to have an entity called products. Okay, so this is what I keep at the back of my mind. Excuse me, I need some more tea. Okay, so at the back of my mind, I know that I probably will need to have at least an entity called invoice, and perhaps another entity called products. Okay, so keeping this in mind, let's try to refine the diagram further. So you can see that this top piece is what we had so far. Now we are adding to it. So we added an entity called an invoice, and the identifier for this entity is pretty obvious. When I looked at the document, you have this invoice number, and that gives me a very natural identifier to use. That's the invoice number itself, and that's invoice date, payment type, subtotal, shipping cost, tax total. Where did these attributes come from? So I looked at this invoice document, and from this document I tried to figure out what are the properties, what are the attributes of the invoice that I need to record in the database. Now the invoice has the customer name, address, state, and so forth, but I don't need to store that information in the invoice, because invoice will be connected to customer. Do you see? Okay, so the entity invoice has been created and it is related to customer. The way I know that it must be related to customer, again, when I look at the invoice, I can see that the invoice has been sent to a particular customer, and I know that I already have the entity called customer in my ER model, so I don't need to store that information again in the entity called invoice. Okay, all right, so I have created the entity invoice, I have connected it to customer in a relationship. So what is the nature of the relationship? What's the cardinality? This is going to be a binary relationship because it's connecting two entities. But what are the cardinalities? In other words, what should the cardinalities be at the two ends? Okay. So let's again, let me expand this picture. So it looks like this. And the way I would interpret it, if I come from customer to invoice, I'll say one customer is associated with at least 0 and at most many invoices. Okay. And that makes sense because you could have a customer who has not bought anything yet. So a customer may be associated with 0 invoices. That's the O in the minimum cardinality. And the customer could have bought lots of things from Heather Sweeney. So the customer may have received many invoices. Okay. Now, if I go in the reverse direction, if I blow up this particular cardinality, it looks like this. They're both ones. Do you see? The inside and the outside, the minimum and the maximum are both ones. So when I come from invoice to customer, I will say one invoice is sent to at least one and at most one customer. So I hope you understand where the cardinalities came from. So the relationship between customer and invoice is one to many. Okay. All right, one last little piece, and then, well, actually more than one piece, and then we'll be done. So you remember when we were looking at the invoice listed some products, isn't it? There's videos that customer called Ralph has bought. So obviously I need to store information about products somewhere in the database. So do you see here? We'll come to products in just a bit. Coming back to the invoice, do you see that there are two separate items in the line items in the invoice? The first line item is a remodeling basics video, and the second line item is a remodeling basics video companion. If the customer had bought a book, that would be a third line item. There would be a book, and there would be a charge for the book. So in general, an invoice has several line items, and each line item is a different product that the customer is buying. Okay, so one invoice could have, it should have at least one line item, because you can't have an invoice unless the customer at least bought one product. But an invoice could have multiple products listed on it, so there could be multiple line items. Okay, so the first thing that we are doing is creating an entity called a line item. But do you notice that it's set up as a weak entity? So you can see the curved ends of the rectangle. And why is it set up as a weak entity? Because you can't have a line item unless you have an invoice. A line item cannot exist on its own. The only way it exists is as a part of invoice. That's why it's set up as a weak entity. And you can see that this is a one-to-many relationship, because one invoice can have at most many line items. So let me expand this picture here. It looks like this. So one invoice could have at least one and at most many line items. Okay, that's the discussion that we just had. And if you look at the identifier for the line item, it's got the invoice number and the line number. So it's a composite identifier. Hence, it's an ID dependent weak entity. That's why the solid line connecting invoice to line item. So I hope you saw where this weak entity called line item came from. Okay, the last thing that we need to do to make this ER diagram complete, again going back to the invoice. So these line items, each of these line items, they refer to different products. You see, the first line item refers to a video product, the second line item also to another video product. If there were additional line items, a third line item could refer to a book. A fourth line item might refer to, I don't know, some utensils, cooking utensils, whatever Heather is selling. Okay. So I will add one more item, one more entity to this ER diagram called product, and its identifier will be product number. Then we have a description of the product, the unit price for the product, and how many items I have in stock of that particular product. Okay. And this entity is not a weak entity, it exists by itself. So product can exist independent of customer, seminar, invoice, and what have you. So this is a regular entity, this is not a weak entity, and it is connected to line item. So every line item can only refer to one product. So if you go back to the invoice, if you look at any one line will not refer to more than one product. So one line refers to exactly one product, but the one product can show up on many different invoices, correct? So this is a one-to-many relationship. So if you look at the cardinality here, again, let me expand it. So the way to read this is, if I go from right to left, one product will show up in at least 0 and at most many line items. Why? Because you could have a product that nobody has bought, so it could show up in at least 0 line items, and of course it can show up in many line items. Now if you go in the opposite direction, this picture, if you look on the right hand side, it looks like 2 bars. That's the cardinality here. So when I go from line item to product, one line item refers to at least one and at most one product. That makes sense, because if you have a line item, it can't be that the line item doesn't refer to any product. It has to refer to a product, and it cannot refer to more than one product. Okay, and therefore you have this, and minimum and maximum cardinalities are 1 in this case. So this is also a one-to-many relationship. Now you can, the more information that you get about Heather Sweeney's business, the more you can refine this diagram. But I hope this exercise has given you a sense of how you go about building an ER model, a conceptual data model from the information requirements of an application. Okay, so you have to know something about the business. You have to look at what kinds of information reports and forms, all those things are used within the application, and from that you would design the conceptual model. So this diagram that you're seeing, this is the ER, entity relationship model, or the conceptual model, conceptual data model for this Heather Sweeney consulting application. Now, after this, our subsequent videos, we will see, when we do database design, we will see how to take a conceptual data model, ER model, and actually build relations from it. Ultimately, of course, we'll have to set this up using some relational database management system like Oracle or SQL Server or Microsoft Access. So just drawing this diagram, this picture is not enough. We'll have to decide primary keys, foreign keys, all those kinds of things. So that second stage of how one takes a conceptual data model and actually comes up with relations, it's what's called database design, and that will be the subject of another series of videos.